All right, so I want to just maybe hit a couple more examples dealing with this sigma notation stuff. And everybody saw the assignment. I did put the assignment up. Okay. So what about something like this? They want to know which of these sigma notation expressions represents that sum. I would just go through and just check them one by one. How about? What about that top one? Take a second and look at that, everybody, and you can vote thumbs up or down on that. Take a second. You can talk it over if you want to. What do you think?
Wait, isn't that just, yeah, good. It's one of those messages. So is one of those answers correct?
Well, maybe more than one are correct.
But for sure, at least one.
Yeah, at least one is guaranteed. Yeah.
Because the top 7. Oh wait, never mind.
What do you think? What do you think about the top one? Thumbs up or down? Okay, I'm giving it the thumbs up. Let's talk about why. How would we know? Let's just check. Let's just check. If we just try these, well, what's the first value of k is 1. That should give us first term. So 2 to the 1 minus 1 is 2 to the 0. Yeah, that's 1. Check. Next term, k is 2. 2 to the 2 minus 1, well, that's 2 to the 1 is 2. Check. Next one, 3. 2 to the 3 minus 1 is 2 squared. That's 4. Check. It's going to work, isn't it? If we go all the way up to the last term, 7, 2 to the 7 minus 1 is 2 to the 6. That's 64. Check. Okay, so it works. Everybody see how that works? So that's good. This guy is good. What about the next one? Starts at 0. What do you think?
Wait, does the number above mean how many times it does it?
No, the number above is the ending value for the index variable. Right, so k is going to go from 0 to 6. So that's good, isn't it? That's going to work too, right? Everybody agree? Okay, 2 to the 0 is 1, 2 to the 2 is 2, 2 to the 3, or 2 to the 1 is 2, 2 to the 2 is 4, etc., right? 2 to the 6 is 64. Yeah, it's good. Okay, bottom one. It's also good, isn't it? It's going to work, right? If k is -1, that gives me 2 to the 0 is my starting value. And my ending value would be 2 to the 5 plus 1, 2 to the 6. Yeah, it's going to work, isn't it? We start at 2 to the 0 and end at 2 to the 6. So they're all equivalent in that case. They all worked. Okay? Which one is the best one? Probably the first one, but they all work. Okay, how about that? Just see if you can find a pattern there. If we're using k for our index variable, what should the argument of that summation be? What function are we summing in terms of k? Yeah, I'll buy that. Everybody agree 1 over 3 to the k? Okay. Make sense? Okay. We don't want to spend too much time on this stuff, but anytime, like what's happening here? We're multiplying by 1/3 each time, aren't we? So anytime we're successively multiplying by something, that must be an exponential, right? We're just increasing the exponent by 1 of the same base, right? So, yeah, what's going to be the top limit? 4. Yep. Okay. Give me thumbs on that. Does that make sense? Okay. All right. Okay. How about that one? And there's a bunch of different answers. Let's just say we're going to do this starting at k equals 1. I'll give you that because otherwise there's so many different ways you could write this. So we're going to do sum of something. K starts at 1. What's the part that's giving us the denominators? Numerator staying 1, isn't it? Everybody agree? So we've got this 1 over something. How am I going to predict the denominators if k is starting at 1?
You could do like, wait, can K go in the negative directions? Can it go backwards?
Well, the denominator, assume we'll take care of the sign part later. Just focus on the number part here for now. Ignore the signs.
So it's K plus 5.
Well, everybody agrees just k plus 5, isn't it?
Yeah, well,
We're just increasing by 1 every time, so we're just adding 1 every time. Does that make sense? As k increases by 1, the denominators increase by 1. So that's just k plus 5. So that's taking care of the values of the fractions. What about the coefficients, the signs, though? What could I do there? Let's put something out here, a multiplier out here that's going to take care of the sign. What is it going to be? Yeah, there you go, right? How do I make the signs oscillate between negative and positive? Well, how could we do that? Something that's going to be -1, next time +1, next time -1, next time +1. Those are just going to be the odd and even powers of -1, right? So that's just -1 to the k. Oops. So there's our answer right there. Make sense? And I could just put the -1 to the k in the numerator if I want to. That's fine. Okay, everybody see that? Okay, so let's talk about this one together here. This is just kind of a property of sums that will make sense to you. If I know that the sum of this, whatever a sub k is, that's just some function of k. If the sum of a sub k from 1 to n is 7, and the sum of b sub k from 1 to n is 12, then what do you suppose the sum of the quantity b sub k minus 3a sub k is going to be? Using properties of sums, remember I can sum term by term, and I can pull constants out front, right? We see how we're doing this? So we could just make this first one, we could rewrite this as, oops. Oh, darn it. There we go. Oh my gosh, that's terrible. I'm not very good at those sigmas. Sum of, I'm just going to do that instead of writing everything else. That just means this, how about? Okay, so the sum of b sub k minus 3 times the sum of a sub k, which just means all that stuff. So what's that? 12 minus 3 times 7, right?
So what does it mean that the k is below it?
Well, that's just saying, I mean, they're just not telling us what that is. B sub k might be k squared plus 4. Who knows what it is, right? They're just telling us that that represents some sum, okay? Whatever b sub k is, its sum from 1 to n is 12. We don't even know what it is, but we know what the value of the sum is, right? So this is all about just understanding the properties of summations, right? And the important properties are, what are we doing? We're splitting it into two separate sums, and we're pulling that -3 or that 3 out in front of the second sum, okay? Does that make sense? Okay, so that's all this is about. So what do we get then? 12 minus 21 is what, -9? Okay, good. All right, last one. Why did I put that one on? Oh yeah, let's just quickly practice using the summation formulas. So what am I going to do here? we did this yesterday. This should just, let's not spend a lot of time on this one. We're using bottom one, right? What's n? 12. Okay, and that's all that matters. Is this is the sum, right? But how many terms are we adding up? If we're adding 12, then what's the answer going to be? Okay, yeah, 12 squared times divided by 4. Okay, so whatever that is, I don't want to think that hard. Right? It's that, I guess. Okay, 6,084. Okay, good. All right, so that kind of closes that chapter.